Welcome to the ET-380 lecture video on satellite communication. Okay, let's get into some basic satellite terminology. So this is a circular orbit, or it's actually circular around the Earth. This is the other path, an elliptical path, which forms an ellipse as it goes around the Earth. Here's elliptical orbit again. This is the geocenter of the Earth, and this is the perigee. And it is the short side, and apogee is on the long side of the ellipse. Okay, here's a geosynchronous path, and this is in red. And it's a satellite around the Earth, a period that's equal to the Earth's rotational period, around 23 hours and 56 minutes and 4 seconds. And it's approximately 22,236 miles above the Earth, and appears to move across the sky as the Earth rotates. Here's a geostationary orbit, and it goes around the equator. Okay, geostationary orbits are circular, and they're directly above the equator. It has no inclination. It's approximately 22,236 miles above the Earth. Has no eccentricity, located directly above the equator, stays fixed over a single point on Earth, appears fixed in the sky to ground observers, ideal for applications like satellite television and telecommunications. Here's some breakouts of satellites. Low Earth orbit. Its orbits relatively low altitudes, 160 to 2,000 kilometers. It completes an orbit quickly, about 90 to 120 minutes, and it's used for satellite internet. Medium Earth orbits, MEOs, are altitudes 8,000 to 20,000 kilometers. It's used for navigation in systems like GPS. Geostationary orbits, they orbit a fixed point above the Earth equator, appearing to stay in the same position relative to the Earth, and it's used for broadcasting, telecommunication, weather monitor. And we have approximately 600 geostationary satellites. So satellites are used for telecommunications, broadcasting, data communications. So active versus passive. Active satellites amplify and retransmit the signals. Passive satellites simply reflect them. Radio frequency RF versus optical. RF satellites use radio waves, and optical satellites use lasers for communication. And here's a picture of a satellite and its basic systems. So it has an antenna, orientation and propulsion system, batteries, a transponder, and solar cells for powering. The GPS is a system of 30-plus navigation satellites circling the Earth. Once the receiver calculates its distance from 4 or more GPS satellites, it can figure out where you are. And this system, GPS, is for the US only. Here's an animation of satellites, GPS satellites particularly, and as they grow over the years. So this is between a period of, looks like 2013 and 2018. Since we're talking about satellites, let's take a look at space junk. 1957, clear. 92, pretty heavy. 2015, look at the mass amount of trash and debris we've left up there. And at 2025, you can imagine. Here's a diagram of satellite ranging with one satellite, two satellites, and three. So one satellite, we have a large distance. Two of them, our area shrinks. Three of them, we must be in this area right now. So 3 satellites is better. 4 would be even better than this. The US is not the only one with GPS type navigation satellites. So the US is called GPS. We have 31 satellites. GLONASS is Russia, and they have 24 satellites. And we have Galileo, which is the European Union. They have 24 satellites, and they're targeting for 30, which they may already have hit. and the BDAO from China. Okay, the main uses for GPS is location, navigation, tracking, mapping, and timing. In order for GPS to work, we have to have very, very accurate timing, which we could also utilize. Here's a diagram of navigational satellite frequencies, and it's breaking it all down. And in the United States, we have a L1, L2, and an L5 band. Okay, the GPS L1 band is at a frequency of 1575.42 megahertz. It carries the coarse acquisition code C/C and the precise P code, which is military use only. And it is more accessible and widely supported by GPS receivers. Its signal can be affected by obstacles and interference. GPS L2 has a frequency of 1227.6 megahertz. It carries military codes P, Y, and a civilian code L2C. L2C offers improved accuracy and signal strength, making it better penetrating obstacles like buildings and trees. The newest GPS L5, has a frequency of 1176 megahertz, and is used for safety, live transportation, and other demanding applications such as aviation. This has allowed for GPS instrument landings and GPS navigation. Here's a diagram of a transponder, transmitter, receiver on a satellite. So we have receiving antenna, low noise amplifier, an LNA, down converter, intermediate frequency as a bandpass filter, RF pre-filter, and a high power amplifier. And these frequencies usually are different between receiving and sending. There's a diagram of a uplink coming from source and a downlink from the satellite to the ground.